Welcome to our fruit classification AI project. In this tutorial, we'll learn how to use Python and machine learning to teach a computer to recognize different types of fruit. First, we'll set up our coding environment. We're going to use Google Colab, which is free and makes it easy to run Python code in the cloud. We need a dataset with images of fruit. Let's download a free dataset from Kaggle or any open source repository. We will now download the fruits dataset for use in the Google Colab. Note the 6 subfolders for fresh apples, fresh bananas, fresh oranges, rotten apples, rotten bananas, and rotten oranges in the fruits dataset. Click the Download button on the top right and select the option for the zip file to download the entire dataset on your computer. Extract the archive zip file to restore the 6 folders for fruits data. You can check the images inside the folders to ensure the contents in each folder. You may be able to see the variations in images, which is an important requirement of data set for training models. Create a fruits dataset folder in your Google Drive and upload all the folders one by one to the fruits dataset folder on your drive. You will find it easier to access and reuse the dataset in your Google Drive by connecting it to the Python code in Google Colab Notebook. Open your web browser and go to https://colab.research.google.com. Sign in with your Google account. On the main Colab landing page, click New Notebook. A new notebook will open with a blank, untitled document. Click on +code on the left to generate a grey cell for coding in Python. Just to get familiarized with Colab Notebook and write a short Python code in the grey cell, such as print, open parenthesis, hello world close parenthesis, and run it by clicking the black arrow on the left. You should see the result on the screen. We are now ready to build our model in Google Colab. Run the small Python code to mount your Google Drive. You may have to allow access and give permissions to make the fruits dataset folder available for use by the Python code for processing. In this segment, we define and train our Convolutional Neural Network, or CNN, using TensorFlow and Keras. First, we import the necessary modules from TensorFlow. The sequential model allows us to build the network layer by layer, while layers like conv2d, maxpooling2d, flatten, and dense enable us to design the structure of the CNN. We define the model architecture, starting with a convolutional layer. The first layer applies 32 filters of size 3 by 3 to extract features from the input image. We use the ReLU activation function to introduce non-linearity, helping the model learn complex patterns. The input shape is specified as 64 by 64 pixels with 3 color channels, red, green, and blue. Next, we add a max pooling layer, which reduces the size of the feature maps, making the model more efficient while retaining the most important features. We then stack another convolutional layer with 64 filters, followed by another max pooling layer. This deeper structure enables the model to learn more complex and abstract patterns in the data. After the convolutional layers, the output is flattened into a one-dimensional array. This step prepares the data for the dense or fully connected layers, which perform the actual classification. We add a dense layer with 128 neurons and ReLU activation to learn high-level features. Finally, we include the output layer, which uses a softmax activation function to predict probabilities for each of the 6 classes, such as fresh apples or rotten oranges. A plot of the training and validation is generated by the Python code snippet, calling matplotlib library. A random test on an image of an actual fresh orange image and one predicted by the model is also reproduced here. You can rerun the random test program to generate several comparisons. In follow-up videos, we will try to understand the algorithms and building of such convolution neural network CNN models. Stay tuned for more on similar topics. Please like and subscribe to our channel if you are interested. Also, visit our website at the given URL.